So the purpose of making a graph for IB physics is to get some relevant data from that graph. Really, that's the purpose of every graph. But in this case, we're dealing with Snell's law. So I'm going to rewrite this equation from the data booklet a slightly different way. I'm just rearranging it. But Snell's law states that the refractive index of the first medium times sine of the incident angle should be equal to the refractive index of the second medium times sine of the refracted angle. And our goal in this investigation is to determine what is N2 using a series of data points. So I will be making a graph. Everyone should have the same N1 value. It's 1 because you're starting in air. But if I want to solve for N2, I need to divide N1 sine theta incident by sine theta refracted. This will give me N2. This right here is my clue for what I need to plot in order to get the N2 value from the slope. So this should give me the slope. I mean, N2 I should be able to obtain from the slope. Slope is y values over x values. In this case, my y values would be N1 times sine theta incident, but N1 is just 1, so I can plot the sine of the incident angles versus sine of the refracted angles. Now I know that the incident angles are the independent variable, refracted angles are the dependent variable. If this was my IA, I would probably do the opposite graph just to show what the independent and what the dependent variable was, and then I would generate a second graph of the inverse. But I would mostly do the analysis on this graph where I have sine theta incident versus sine theta refracted. And what you'll see when you plot these points, as we will do here shortly, is a straight line. The slope of this line, when you generate the line of best fit, the slope will give you N2. It will be the refractive index. But that is not sufficient. That's not everything that we have to do because this slope is not perfect. It's made up of measurements that have some uncertainty. I'm really trying to get this aligned. So we're going to have to do error bars to denote this uncertainty. Both vertical and horizontal error bars all the way across. We will add those in Excel. And then using these error bars, we're going to generate two additional lines. One will be the max slope possible. And so all we have to focus on is the largest x and y values. For the largest x value, to make the slope as exaggerated as possible, you want to tip it forward for the largest x values. So I will subtract the uncertainty from the largest x value, but I will add the uncertainty to the largest y value. So for the highest data point, this will be x minus the uncertainty, and it will be y plus the uncertainty. This is for the max slope possible line. For the smallest y value, to help tip this line to the most extreme possible, what I can do is subtract the uncertainty from the y value, add it to the x. So this will be for the max. X plus the uncertainty, y minus the uncertainty. And what you'll see is this kind of forces the graph. It tips it forward. We're just going to try to connect the line as straight as possible. This is for the max. For the min, we do the opposite. We're going to try to make the graph lie as flat as possible. So for min, I will shift down and back. So for the min slope possible, only looking at the two extremes, x plus the uncertainty, y minus the uncertainty. For the minimum point, we do the opposite, x minus the uncertainty, and y plus the uncertainty. So it makes the graph lie flat. If only I could draw a nice straight line. And what you'll see is that the I should have used different colors. You'll see what we're about to do. It will make sense. Hopefully it make more sense, but this is something you will be doing for your IA. Let's go ahead and get after it. Okay, so here I still have the same values as before. Uncertainty in the sign values, I kept them all the same, plus or minus 0.002, and I've put this in. Let's go ahead and insert a chart. You always do a scatter chart. Never a scatter with smooth lines. No, what are you doing? Scatter chart like this, just dots. We'll line the lines for ourselves. If your values get plugged in, if it comes automatically up with some random graph, that's okay. You'll just right click the graph, select data, and you can delete or edit the series. In this case, I'm going to have to add a series. And the series name, this will be sine of the refracted angles, sorry, sine of the incident angles versus sine of the refracted angles. My x values, these will be the sine of the refracted angles. And my y values, these will be sine of the incidence. It's always rise versus run. Okay, we need to add axes titles. This will be, again, sine of refracted, sine of incident angles. I keep wanting to do the opposite. And these will be sine of the refracted angles. I can spell, it's sine, S-I-N-E or S-I-N, it's fine. Sine of refracted angles. And I don't need to include units because these are unitless ratios. Sine is a ratio. Sine of the angle gives you a ratio, so there's no units. We'll add a trend line. Linear, of course. More options. And to display the equation, make sure you click these vertical bars here. Scroll down, display equation on chart. The slope of this graph is my index of refraction for the medium. Your index of refraction should be something totally different. You're doing one of the mystery compounds. Okay, so IB would not just expect me to report the slope as 1.5 or the refractive index as 1.5. This is not a perfect, these datas aren't perfect. Even though I have a very small systematic error, there's still some error involved. So to denote the error in each of the individual data points, we are going to have to add error bars. So click the green arrow, error bars check on, and we are going to format these, more options. It starts off with the horizontal error bars. Perfect. You should have both plus or minus. And we're going to change from standard error to a custom value, which we'll specify. This custom value will be equal to this. For the positive error, that's the plus part of the plus or minus. And this will be the minus part of the plus or minus, keeping the equal sign. Okay, the error bars shrink. Now if I double click, I can, on the vertical error bars, I can now change the size of these. Will again specify custom value, and it will be the same as before, plus 0.02, minus 0.02. Okay, now let's generate the max slope possible. Max slope. We're going to focus on the biggest x and biggest y values and the smallest x and smallest y values from our data set. So my smallest x and y are here. The sign of the incident are the y's, sign of the refractive are the x's. So I'll start with the x value. So in this case, this x value, that's the small one. If I'm making a maximum slope possible, what I want to do is I want to shift it back, and I will tip the maximums forward. So I'll end up shifting this back and down and tipping this one forward. So to shift this to the right, like I want to do, I will add the uncertainty, the range of the uncertainty here. And the corresponding y value is equal to this. That's the corresponding y, sine of the incident angle. And I'm going to shift it down to make it more extreme, so I will subtract the uncertainty. Now I look at the other end of the data set. My highest y and x value is this. So I'll start with the x, typically listed x and y equals, this is my highest x value. And what I want to do is shift it forward. So I have to subtract the uncertainty. And then for that corresponding y value, I want to push it up. Trying to literally, I think about this like rotating type of torque. Okay, these are the data points for my max slope. I'll do the same thing really quick for the min slope. Again, this will be equals my smallest x value. You'll do the same. Smallest x is this, and I will, for min slope possible, I need to subtract the uncertainty, so subtract this uncertainty. For my corresponding y values, all right, corresponding y value, we're going to shift it up. So I will be, oops, sorry, equals, grab the corresponding y. Let's shift up here, add this uncertainty, bloop. And for the maximum x and maximum y values, making our min slope, let's grab this highest x. And if I'm going to try to minimize the slope, I want this to lay as flat as possible, lay down. So I will add this uncertainty to the x value. And likewise, I want to make the minimum slope value lay down flat, as flat as possible. So I will subtract the, oops, I grabbed the x value again, take the y value, corresponding y value, and subtract out the uncertainty. Awesome, here we go. Let's make our max and min slope possible line. So I will right click, select data, and we're going to go to add. I'll title this max slope possible. Series x values equals, and we are going to click, drag, hold. X values come first. Maximum y values, click, drag, hold. Okay. All right, now I'm going to add, whoa, I'll have to bring back my chart title. We can retitle this. I'm going to add a trend line here and more options with the trend line. Wait, sorry. Trend line, more options, and it should come up. I get a choice. I'm going to do the max slope possible. Click OK. And we want to display this equation on the chart. And notice this max slope possible should be larger than my line of best fit. And to denote the difference, I'm going to shade the box. I'm sorry, solid line around this box. Yay, okay, that's my max slope. Let's do the min slope. Add this. Oh, right click the graph, go to select data. We're going to add a new series. This will be called min slope possible, making the min slope possible line. Series x values, let's highlight these. Series y values, highlight these. Click OK. Okay, now I'm going to add, again, the trend line is already clicked on, more options. Let's make this min slope possible line visible. Click OK. Vertical bars, display equation on chart. There it is, and it should be smaller than my min slope possible, sorry, than my line of best fit slope. To denote the change, I'm going to add a line, solid line around the border, and I'll make it gray, just like the data set's data points. So now I have my max, min, and the line of best fit. Okay, so with the chart title, sine refracted angles versus sine of the incident angles. Do not snip this. You're going to go control right click, you will copy, go to your Word document, and you will paste this here. And that's it for this video. Thanks for watching. One more to close out this assignment.